Okay, in this video I'm going to talk about why the multimeter fuse blows when we're measuring current and it does not blow when we're measuring voltage, and how to be careful when using the multimeter to make sure that we do not blow the fuse. So first I'll talk about the multimeter set to voltage. So I'll draw that as a circle with a V. So this is the multimeter set to measure voltage. Okay, so if we have some circuit, I'll just say like a 10-volt battery connected to a resistor, something simple like this, and then this can be like 2 kilo ohms or something. It doesn't really matter. When we measure voltage, what we do is we take our multimeter and we hook up one end of the multimeter to the positive side and one end of the multimeter to the negative side of the resistor, and if we hook it up like this, it'll spit out 10 volts. And when we hook up the multimeter, we want the circuit properties to stay the same. So the circuit properties with and without the multimeter should stay exactly the same. So this is our circuit without the multimeter, and then the circuit with the multimeter, and they should have the same properties. We don't want anything to change. Just because we're measuring the circuit, we want the circuit to behave the same with and without the multimeter. If the circuit behaves differently with the multimeter attached, then we're not measuring what we desire to measure. We desire to measure the circuit, and so we don't want the multimeter to change the circuit. So to do that, currently, in the original setup, we have a current that flows through here, through this resistor down that way. And so we need the current to flow in the same route. We do not want any current flowing up into and through the multimeter. If that happens, the voltage across our resistor will drop, and we will not be measuring the desired current. Does that make sense? Like we will not be measuring the desired voltage. We'll be measuring voltage of some different circuit with the multimeter attached, which is not what we want to measure. So in order to prevent any current from traveling up through this multimeter, then the resistance of the multimeter in voltage mode rises to about like a very high resistance, and I'll call it infinity for simplicity. So now when it has infinite resistance, then no current will flow through the multimeter, and we will have all the current flowing through the circuit, and the multimeter will measure the desired voltage of 10 volts. If our multimeter had a lower resistance, right, if this was also 2k ohms, then half of the current would flow through the resistor, half of it would flow through the multimeter, and we would only measure 5 volts. And this is obviously not what we want to measure. So in order to make sure that the multimeter measures the correct value in voltage, then its resistance rises to a very high number, very high resistance. When we're measuring current, what we do, so if this is the original circuit, 2 kilo ohms with 10 volts, then our circuit with the multimeter is, I'm putting an A there for ammeter, amps, it's reading amps. This is the circuit with the multimeter. So now the circuit measures the current, or the multimeter measures the current that is flowing through the multimeter. So we apply the same principle here. We want our new circuit with the multimeter to behave exactly like it did in the original circuit. And so what we do is we have the resistance of the multimeter become approximately 0 ohms. This way, it has no effect on the current, and the current reading is the exact same as it would be in the original circuit. They have the same current for both the original circuit and the new circuit. The issue with having our multimeter at 0 ohms is, so in this circuit, notice that all of the voltage drop, we have 10 volts dropping across here, and then these points in green here are the same electric potential. Okay, there's no voltage across the ammeter. It's very important. Once you put a voltage across the ammeter, let's say we had a circuit with the ammeter, right? So if you, I'll do a common mistake that people make. If we try to measure the current the same way we do for the voltage, right? If we have 10 volts across this battery, then we'll have 10 volts across this ammeter, right? And because its resistance is approximately 0 ohms, then the current across this multimeter will be very, very high. We'll have a current of I equals V over R equals 10 over almost 0, which gives us almost infinite current. And so the power flowing through this resistor is going to be incredibly high. We have power equals, we'll do V squared over R, because those are the givens. We know the voltage and we know the resistance. The current is a calculation from the other, so we use V over R. So this is 100 over basically 0, which is infinity. So we have infinite watts flowing through our multimeter. And what this does is it generates lots and lots of heat. That all the power that's absorbed by the multimeter is converted to heat. So the multimeter heats up really fast. And you may have seen, but if you do something like this with one of the resistors, you can burn the resistor and get a lot of smoke, and the resistor won't work anymore. So the same thing would happen with the multimeter. The multimeter would heat up and no longer work anymore. And so what the designers of multimeters do is they put a fuse inside the multimeter. So all the current that flows through the multimeter will first pass through a fuse. So here's inside of our multimeter. All the current first passes through this fuse. Then it passes through the rest of the multimeter, mumbo jumbo, all in there. And what the fuse does is it says any current above some certain amount. So for ours, that's 500 milliamps for one fuse. And there's another fuse actually inside of our multimeter. And that's a 10 amp fuse. Any current above this 500 milliamps, then it will blow the fuse. The fuse will blow up, melt, and no current will be able to travel through that path. What this does is it saves the rest of the multimeter from being burnt. We burnt the fuse, but the multimeter will be okay. All we have to do is put in a new fuse, and our multimeter will be good as new. They do this that we can replace just the fuse instead of replacing the whole multimeter. But we do have to be careful that we don't run a current higher than 500 milliamps through the multimeter. And to do that, the voltage will always have to be approximately, the voltage across the multimeter will always have to be approximately 0 volts, like we have over here. Any voltage across the multimeter and you'll blow the fuse right away when you're measuring current. When you're measuring voltage, it is not a big deal because the voltage resistance is almost infinity and you'll get no current flowing through the multimeter. So when you're measuring current, this is why we just simply break the circuit. So if we have resistors in parallel, right, and then they're all hooked up to some battery. And we want to measure the current through the resistor. If we hook up our ammeter like this, boom, that's a fried multimeter right there. It's super easy to fry the multimeter. what we want to do to measure the current through one of these resistors is stick the ammeter right there, so that all the current that passes through that resistor also passes through the ammeter, and there will be essentially 0 volts across this ammeter, which is desired, so then we don't have an infinite current and we don't blow the fuse. I hope that makes sense, and I hope after this nobody blows any more multimeter fuses.